Hello everyone, welcome to another lecture on the topic of trigonometric equations. With respect to trigonometric identities, we said that those are mathematical statements that are true for all values of the variable. But in case of trigonometric equations, these equations are not true for all real values of the variable, but they are only true for certain values of the variable. And what we want to do is to learn how to solve not quadratic, but trigonometric equations. So if you have an equation in the form of, let's say, sine theta is equal to 0.5, or even cos theta equals some number 0.48, or tangent of theta equals 26.12, all of these are different examples of trigonometric equations. And the purpose of solving trig equations is to find the value of theta that satisfies those trigonometric equations. If you have sine theta equals a number, let's say k, you have learned this, that you can find the angle by pressing the inverse sine button on the calculator. So inverse sine of that value k is equal to theta. I call it theta sub 1 because there's always two solutions within one full cycle of 360 degrees, within one full revolution on a unit circle. There's always two solutions. One solution is very clear. Theta sub 1, you press inverse sine of the number k, the answer is your first angle. But then the second angle is pi minus inverse sine of k. Pi minus whatever you had on the screen of the calculator. When I say pi, I mean pi radian. And in terms of degrees, it would be 180 degrees minus theta. Let's say you have sine of, let's say you have sine theta equals 0.5, okay? So when you punch in inverse sine of 0.5, you get the answer as 30 degrees, okay? And that's your first solution. So I call this theta sub 1. But there's always a second solution, theta sub 2, which is 180 minus 30 degrees. 180 minus what you saw on the screen of the calculator. And in this case, it's going to be 150 degrees, okay? Now, 30 degrees is called the principal angle. We have talked about it in the past, principal angle, because it's the smallest positive angle, okay? But there's also a second solution to the trigonometric equation, which is 150 degrees in the second quadrant. So why don't you grab the calculator, punch in sine of 150, you see that it is equal to 0.5, it satisfies the equation. But other than 150, 30 degrees also satisfies the equation. So that's what I mean when I say there's two solutions within one full revolution of a circle from 0 to 360 degrees. So that's the story of sine, and we can actually try a couple of exercises. Sine of theta equals 0.35. So if you want to find theta itself, it would be inverse sine of 0.35. You can try with your calculator. It's going to be 20.5 degrees. This is the first solution. The second solution, you have to always remember, it's 180 minus this. So theta sub 2 would be 180 degrees minus 20.5, and that would be 159.5 degrees. So basically, we found two solutions within the interval of 0 and 360. So I'm going to define here some sort of domain. I'm going to say theta is between 0 and 360 degrees. That's a given domain. So within this given domain, solve the trigonometric equation basically, okay? So 20.5 degrees and 159.5 degrees are the two solutions for this first trigonometric equation. If you want to do the other one, so once again, inverse sine of negative 0.82. You're going to try to find the answer and you end up with negative 55.1 degrees. Okay, the second solution would be 180 degrees. Take away whatever you see on the screen of the calculator. So negative times negative is going to be positive. The answer would be 235.1 degrees. So this is one admissible solution for the trigonometric equation. But the other one, I'm not saying the calculator was wrong, but I'm saying it's inadmissible because we ended up with a negative answer. We know that the domain is from 0 to 360, so we can't have an angle less than 0 degrees because it's out of your given domain. So negative 55.1, it is a correct solution to this trigonometric equation. I'm not saying no, but it's not admissible because it's not within the given domain. So you may say, okay, what am I going to do so that it would be within the given domain? Well, negative 55 degrees, if you draw the angle in standard position in your mind, it's going to be in the fourth quadrant. So how can you make an angle with the terminal arm, angle in standard position with the terminal arm in the fourth quadrant such that it is positive? So you have to add 360 degrees and come up with a co-terminal angle with negative 55.1 to make it a positive angle within 0 and 360. That is the trick. So what we're going to do, we're going to say, okay, theta sub 3 is negative 55.1. We're going to add 360 on purpose. We do that so that the angle will fall in the fourth quadrant as it is supposed to be in the fourth quadrant, but this time with a positive value. So 304.9 degrees. Okay, so this would be the admissible solution. And 304.9 degrees is an angle which is co-terminal with negative 55.1 degrees. They share the same terminal arm. They're both in the fourth quadrant, except that one is negative, one is positive. Both are correct, both are valid, both satisfy the equation. But why did we count the first one inadmissible? Well, because it was not in the given domain. That's the only reason. Okay, so that was the story of sine. And about cosine, again, inverse cosine of k would be the first solution, but the second solution is 360 degrees minus theta sub 1. In radian would be 2 pi minus inverse cosine of k. And for tangent, the first solution is obviously inverse tan of k, and the second solution would be pi plus inverse tan of k. These are summary formulas that are very handy if somebody knows and uses them. So for this one, I will take the inverse cosine of 0.48. The answer is 61.3. I assume that you are checking with your calculators. And the second solution, it says 360 minus theta 1. So 360 take away 61.3 degrees. That would be 298.7 degrees. Now, if you plug these angles in the equation, it definitely satisfies the equation. You can definitely try, and you should actually. So for this other one, again, we take the inverse cosine of negative 0.45. The machine, the calculator, will give you 116.7 degrees. And the second solution would be 360 take away whatever you see on the screen of the calculator, which would be 243.3 degrees. So again, we found two solutions, theta sub 1, theta sub 2, for that given trigonometric equation. Story of tangent, nothing different. Inverse tan of 26.12. Punching on the calculator, it is 87.8 degrees. So that's one solution. The second one is 180 plus theta 1. So I'm going to add 180 with this angle that I just got on the screen of the calculator. 267.8 degrees is the answer for the second solution. This one again, theta sub 1 is inverse tan of negative 11.53. We are going to use the calculator. We end up with a negative angle once again, so it's 85 degrees but negative. And theta sub 2 is 180 plus whatever positive or negative you saw on the screen of the calculator. So that gives you 95 degrees, a valid admissible solution, but negative 85 is not admissible for the same reason I explained earlier for the case of sine. So what we're going to do, we're going to go after a co-terminal angle by adding 360 with negative 85. We are going to find the answer, which would be 275 degrees. 275 degrees. So 360 minus 85, 275 degrees. And 275 is actually in the fourth quadrant, just like negative 85 degrees is in the fourth quadrant. But negative 85 is a negative angle, but 275 is a positive angle, but they both share the same terminal arm in the fourth quadrant. So remember, those three formulas are becoming very handy, and you can actually solve any kind of simple trigonometric equation like all of these using those three formulas and those simple rules. For this equation, sine theta equals 0.5, I mentioned earlier that the first solution is 30. The second one is 180 minus 30, which is 150. That's true. But if I say the domain is between 0 and 360 degrees, and you're going to say these are the two solutions, no questions asked. You're right. But what if I say the domain is from negative 360 degrees all the way up to 720 degrees? What if I make a larger domain, give you a larger interval? Then you have to search for more angles within that bigger interval. And how do you search? And that the search is by finding coterminal angles with these two angles. How do you find coterminal angles? We have discussed it in the past. You keep adding 360 or subtracting 360. So 30, I'm going to add 360. I'm going to get 390 degrees. If I add another 360, I get 750 degrees. If I keep adding another 360 degrees, which means making another full revolution around the circle, it will be 1110 degrees, and so on and so forth. You can keep adding 360 or subtracting 360, which will give you negative 330 degrees or negative 690 degrees if you subtract another 360, or negative 1050 degrees, and so on and so forth. Now you can do the same thing with the second solution of 150 degrees. So again, keep adding 360 and you will end up with all these angles, and even you can continue or you subtract. So 150 minus 360 would be negative 210 degrees. Subtract another negative 360, that will be negative 570 degrees. And then negative 930 degrees, and so on and so forth. It goes like forever. So all of these angles are coterminal angles with the two main angles. The first one is the principal angle. The second one is just the second solution within 0 and 360. Now, because the domain is larger, we have to grab those that fall within the domain. So I would say, for example, solution set. If I take the solution set, I'm going to say negative 330 must be taken into account. I would say 30 itself must be taken into account. I would say 390 is considered to be admissible. 750 is larger than 720, so that doesn't count. I stop. The other one, 150, counts. And then 510 also counts because it is less than 720. 870 doesn't count. From the other side, negative 220 counts. And that is it, because negative 570 is less than negative 360. So 1, 2, 3, 4, 5, 6 solutions we found for this trigonometric equation sine theta equals 0.5. 6 solutions for that equation if the given interval is a bit larger. Now imagine if the given interval is a set of real numbers, you have to write like infinite number of solutions basically. So you always look at a given interval which is sort of attached to a trigonometric equation. Always when they ask you to solve a trigonometric equation, they know that there is infinitely many solutions for any trigonometric function for an obvious reason, because these equations, trigonometric equations, which come from trigonometric functions, they're periodic functions. So because trigonometric functions are periodic functions, they have so many solutions, infinitely many solutions. And usually they don't want you to find millions of solutions. That's why they restrict the domain from 0 to 360, like in our first exercise. I did 6 questions for you. Or if they want to give you a bigger domain, still they have to restrict it. Otherwise, you're going to have infinitely many solutions. So whenever you see a trig equation, you always see a given interval attached to it, basically. Otherwise, if the domain is a set of real numbers, you have to sit down and write infinitely many solutions. Or you can write your answers in terms of some parameter k, where k is an integer. That's also possible to do, but we're not discussing it right now. I hope you understood how we are dealing with basic or simple trigonometric equations, and I'll give you more advanced examples, and we will do quadratic trigonometric equations as well in a separate lecture later on. Thank you, and keep practicing.